Alright, so up until now, what is the big formula that we use to find things for triangles? The Pythagorean theorem. Okay, what else do we use when we're dealing with angles of triangles? Your trig function, sine, cosine, tangent, sometimes they're reciprocals, yeah? What type of triangles do all of those things apply to? Right triangles. So what happens when we have wrong triangles? We cry, okay. No. Will those formulas work for that? No. So what do we need? A different formula. A new formula. Okay? Which is what we're going to be talking about. And there's actually two options. One is the law of sines, one is the law of cosines. And it's going to depend upon the information that you're given, which one we want to use. So what is an oblique triangle? So there are no such things as actually like wrong triangles, right? But there are oblique triangles, which means that it is a what? A not right triangle, yes. So it is a triangle with no right angles. Which is why we can't use our previous step, okay? Now, some of us might have seen the laws of sines, laws of cosines in our geometry classes. I know for a lot of people that was like the thing you didn't get to. So basically, I'm just going under the assumption that you've never seen this before. So if it is a little bit of a repeat, that's all right. It's just a refresher. But I want to make sure we're all on the same page. So hopefully we do remember from geometry our different cases for congruency. Yes? Mm-hmm. So like side, angle, angle, side, angle, all of those things. Okay. So we have angle, angle, side, or angle, side, angle. Both of those are previous congruency properties. Now, on the second one, okay, you were probably told that you can't use side, side, angle. Okay. It does need to be in that order. Okay, my friends? Got it. Thanks. So you were probably told that you can't use that one, and that's because it's a little bit tricky to use, and that's what's going to be called our ambiguous case for law of sines. So that's what we're going to do tomorrow. So these first two are using our law of sines. The second two are what we use for our law of cosine. Alright, so like I said, the first two, so mostly today we're going to look at the first two cases, angle, angle, side, or angle, side, angle. Tomorrow, this is our ambiguous case, so we're looking at side, side, angle. And then Thursday and Friday are our last two for law of cosines. Now, what congruency property or combination is not up there?
Angle, angle, angle.
Why can't I use angle, angle, angle?
Because the angles can be the same, but the sides can be different.
Correct. So it creates what types of triangles?
Similar.
Similar triangles. And how many similar triangles can I make that have the same angles? An infinite amount, right? So as long as they keep basically the same proportion, they're going to have an infinite number of side options. So that's why we can't use angle, angle, angle to find anything else. Okay, we have to have at least one side given somewhere in order to be able to find other things about it. Okay, so here is our law of sines. We will have to have this memorized. So whatever you put in your notes, a star, a highlight, underline it, you do have to have your law of sines memorized. Now, notice that there are three parts to it. Okay, we have three separate ratios here. We don't ever use all three ratios at the same time. Usually we're only going to use 2 parts of it, so we would do like our A ratio equals our B ratio, our B ratio equals our C ratio, or our A ratio equals our C ratio. But we can do any combination of it. So that's why it has the 2 equal signs instead of just writing out like 3 different options of the equation. Saying you can do them in any order. Now, notice that all of these have our sides on top. That's what those little letters mean. We can also rewrite it by flipping all of them so that our angles are on top. Depending on what you're solving for, that's, it's easier if I'm solving for an angle for my angles to be on top. So, it's the same thing though. So sometimes you'll see it written like that. Depending on what you're looking for, they're the same thing though. Now, for our picture, the biggest thing about the picture is notice what is the relationship between our little letter and the associated angle. They have to be opposite of one another. So notice that angle A, opposite of that is little a, angle B, opposite of that is little b, and angle C, opposite of that is little c. So a lot of times your picture might look slightly different than somebody else's picture because it's the triangle's been like rotated, but as long as you have the correct things across from each other, then your setup and your equations will be the same. Does that make sense? And also sometimes you might see it written with other variables. So just like with our Pythagorean theorem, it's just side squared plus side squared equals hypotenuse squared. These are basically all just side over the opposite angle, side over the opposite angle. So even if there's other variables, you can still set it up the same way. Bring out with me. Do we have that written down? Yes. So let's look at an example. So it says for the triangle in the figure, big C equals 102 degrees. Big B equals 29 degrees, and little b equals 28 feet. Find the remaining angle and sides. So what are we going to do? Correct. Is there anything that's going to be easier to find than that? Yeah, we can find our last angle, right? Because what's the relationship between the 3 angles of a triangle? The sum has to be 180, so even without knowing basically any of our law of sines, law of cosines, we can find our missing angle. So we know that angle A has to equal 180 degrees minus big B minus big C. Agreed? So what do we get? 149 degrees? Yes? No?
C equals 102. I think it's just.
You might check yourself on the calculator. We are going to need our calculator when we start getting into the law of sines, law of cosines, because that's going to give you not nice decimals. So
180 minus 102 minus 29.
yeah, so you would do 180 minus 102 minus 29. Or minus 29 minus 102. Doesn't matter the order. You're subtracting both of them. So what do we get?
49.
So just 49 degrees? That sounds a little bit better.
That's what I said.
Okay. So 49 degrees. So do we indeed have an oblique triangle
Yeah.
or any of those 90 degrees? No. So we do not have a right triangle, so we can't use our Pythagorean theorem to find our missing sides. So what do we have to use? Law of sines. Now, specifically, which one do we have here? Which case? Yes. Angle, side, angle. Because we're given two angles and then the side that's in between them. Agreed? Alright. Yes? So that's why we're in our first one. Or if you wanted to do it the other way, we had angle, angle, side. Whichever way you looked at it. So, now when we're using our ratio, we want to think about two things. One, what we're looking for, and two, what we're trying to find. What they give us to find. So, on our first one, what do we want to find? A or C? It doesn't matter. So, I have C. If I'm trying to find C, I have to use my C ratio. Are you with me? So then, what do they give us? We have all three angles, so that's not really going to determine it. But my ratio, right, I don't know what small c is. I know what big C is. So on my other side, I have to know both of those values in order to be able to solve for little c. So which one is the only one that we know both of those values for? B. So if the only side that I know is B, we have to use our B ratio. Does that make sense? We're all with me? So then I'm just going to fill in. So I have sine of big C, we said was 102 degrees. Little b is 28 feet. And big B is 29 degrees. Agreed? So how do I solve for little c?
Cross.
No.
Can't you just like divide A by the sine of 29 and multiply by the sine of 20?
Yeah, so I'm just going to do what? Multiply sine of 102 to the other side, right? So I would get C equals 28 divided by sine of 29 degrees times sine of 102 degrees. And then this is where we would need to plug everything into our calculator. We're not going to be dealing with right angles, so we're not going to have angles that are on our unit circle. So the only way that you can get an answer is to approximate it. So little c is approximately what? 59 point what?
So 56.49.
So make sure we're in degrees. And then make sure that you ended your parentheses after your 29 degrees. Okay, so what is it? 50.044. Did anyone else get that?
49. Yeah, that's what I got.
I got
56.49. Any check skills? Calculators.
Did you separate a 102 from the fraction? Did you multiply 40 divided it on?
Yeah, it should be 56.
I don't know what I did.
Decimal.
Did you multiply 28?
So it should be 56.493. Alright, and what unit are we in?
Degrees.
Oh,
Oh, this one.
feet.
Yeah.
I meant like the unit of our answer. Okay? So then, now I want to find what?
A.
Little a. So, we know what we want to find, so we have to use that ratio. Now, technically, do we have both of our other sides now?
Yeah.
Yes. But what did we have to do to get side C?
Approximate.
We had to approximate it. So if you use an approximated answer, to find another answer, basically you are increasing your rounding error. Does that make sense? So if at all possible, we want to use things that they gave us, which again, they gave us both little b and big B, so we can go ahead and just use that ratio again. Now, there will be some questions where you have to use the information that you found to find the next thing, and there's just not a way around that. In those cases, basically you just want to wait as long as possible to try and round things. But in this case, we had enough information where we don't have to use our rounded answer. So from here, our setup is going to be quite similar. I have sine of 49 degrees, again, equals 28 over sine of 29 degrees. What do we need to do to solve for A? Multiply, so we have 28 divided by sine of 29 degrees times sine of 49 degrees. And what do we get?
Got a 43.58.
43.588.
Yeah.
What is it?
43.
43. Okay, and again, we are in
Feet.
feet. So we found the two missing sides along with the missing angle. So those are my three answers. Questions on that? The biggest part with these questions is just the setup, because then from there it's basically plugging and chugging. You're gonna plug lots of stuff into your calculator. Alright, we're going to look at another one. So in this one it says solve the triangle. What does that mean?
The side of the triangle.
Find the rest of the values. So basically they give you some pieces of the triangle, you need to solve for the rest of the pieces of the triangle. What did they not give us this time?
The picture.
A picture, right? So again, you don't have to draw a picture, but usually it's helpful just to make sure that you're keeping all of your sides and angles in the correct way, basically. Now, the way that I draw my triangle might be slightly different than how you label your triangle. Again, it doesn't necessarily matter which angle you label as what. The biggest thing is, where do we have to make sure our sides are? Opposite of their associated angle. So like I'm gonna make my big A on the left hand side. You could have easily made your big A on the right hand side. The only thing you then need to make sure is that our little a has to be directly across from that. Does that make sense? So big A is 30 degrees, big B is 45 degrees, and they also give us that little a is 32 feet. Agreed? So what do we need to find again?
Last angle.
Mm-hmm. And then
And then plug it into the.
your law of sines, so we need to find our two sides, yes? So again, how do I find big C?
Subtract A and B from 1.
Agreed. So minus A minus B. So what do we get? Okay with that? That's always the easiest one to find. So then what do we want to find next? One of the sides, doesn't matter which one?
No.
Not really. So which one do we want to find first?
B.
B? Sure. We'll go alphabetically. So we're looking for little b. What is big B this time? 45 degrees. So I'm using my B ratio because that's what I'm looking for. And then what other ratio do we need to use?
Little a on the side.
A. We need to use our A ratio because that's the information that they give us. So 32 divided by sine of 30. So what do I do to solve?
Multiply.
can we get that B is approximately
Oh. Why did it? I got 42
45.
square root of 2.
I got 42, so it's 40.
That's, I guess that's the exact.
that is because notice 30 and 45 are both on our unit circle, but we want the decimal approximation.
So it's 45.255 feet.
So yeah, on this one you could get an exact number, but we wanted to just go ahead and round it. So then how would we set up our little c? So we would have little c divided by sine of 105. Again, we want to use the information that they gave us. So c equals 32 divided by sine of 30 degrees times sine of 105 degrees.
What is it? I got 61.819.
So we get that c is approximately what?
61.819.
And again, we are in feet. So there are my two sides and our angle. Yes? So like I said, on both of these, we were looking for a missing sides, or we found the other angle because we were given two angles. Tomorrow, we're going to look at how to find an angle using our law of sines instead. Okay? But the last thing that we're going to look at today is the whole point of this stuff, or laws of sines and laws of cosines, is because we can use them for our application problems. Yay! Which is what your project's going to be over. You're going to be creating your own application problem using law of sines and law of cosines. So this tells us a pole tilts towards the sun at an 8-degree angle from the vertical and it casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? So what might it be helpful to do? If they don't give us a picture, usually it's helpful to draw a picture. Now, what are my pole and shadow going to be dependent upon? It says my pole tilts what? Toward the sun, right? And then our shadow will have to be the opposite direction of the sun, right? So we probably want to draw a sun somewhere. That is the extent of my artistic abilities, guys.
These have smiles.
Sure.
Sunglasses.
Sunglasses. Yes. Oh wow. Now I'm understanding it.
Alright, so that means that if I draw my pole, it has to tilt toward my sun. Agreed? And then our common reasoning skills tell us that the shadow has to go in what direction?
Straight down.
Away from the sun. Yes, because that's how shadows work. And then what other information do they give us?
It's
The
22 feet.
tip of the shadow to the top.
Yeah, so the last part is the tip of the shadow to the top of the pole. So that's going to be this angle that's created. Then we can start to label. So yes, we know that this bottom side is 22. We know that our right, not right as in 90, but as in the right side angle is 43 degrees. Okay. Do we know any other information?
We know the
8 degree.
the position, yeah.
So 8 degrees is this whole thing.
I don't think
Like
so. I
98?
think it's the,
90.
from the vertical.
So notice that this, so from the vertical would create a right angle. And then we know that from the vertical would be an 8-degree angle. So what is that total angle on that side? 98 degrees. Just like the band.
That's a band.
It is. They were like the first One Direction. Before NSYNC, before Backstreet Boys, 90 degrees. Alright,
Why is that the same?
I have no idea. Alright, so what are we looking for then?
The height of the pole.
How tall is the pole?
So this side, right?
Yeah.
Okay? So if that's the side we're looking for, are we going to be able to use a trig function?
No,
Why not?
this is not a right angle.
Well, there is, but there's not one that's included in the entire triangle. Agreed. Okay, so what are we going to use instead? Our law of sines. Do we need any other information in order to be able to use our law of sines? So I have this side that I'm looking for, right? My angle that is across from it. So that's going to set up my first ratio. So sine over 43 degrees. But then remember, we need both pieces on our second ratio. We have 22, agreed? So that's what would go on top, but what needs to go on bottom there?
That opposite angle.
The opposite angle. So that would be the angle that's up by my sun. So how do I find that? 180 minus 98 minus 43. So what do we get? What? 39 degrees?
Yeah.
Okay. And again, just like with all our other ones, how do I solve for x? Multiply. And then plug into our handy dandy calculator. So what do we get?
23.
841?
Yes.
No, wait.
No, 842.
Because the five are right up.
Gotcha. Questions on that? So even though it's an application problem, it's still basically doing the same stuff. You just have to figure out how to label your picture. That's the hardest part. And that's how most of the time in your application problems, it's not going to ask for, like, to solve for all of them. The only thing it might say is, like, if it was like a 2-part question, it could say, like, if somebody's wanting to look up at the sun, what's the distance between them and the sun, or something like that. It could, like, give you a couple different parts, but most of the time it won't. The only thing is sometimes it might do kind of like what we did here, where we had to use the 8 degrees to, like, find that angle. So sometimes it might give you other pieces and not necessarily, like, the entire part. Questions? Concerns? Comments?